Good morning, good day, and welcome back to another Metrel webinar. My name is Mojca and I will moderate today's event. Our presenter is one of our product manager, Mihael Hribar, and he will introduce our newest addition to the family of Power Quality Analyzers, the MI2992. Janez Guzel, Director of Application and Technical Consulting, will be the host and operator and available at the end together with Mihael to answer to your questions. Before we start with the presentation, we will see some simple rules we kindly ask you to follow during the webinar. All the participants will have muted microphones. During the lecture, we won't be able to react to raised hands. Please write your questions to chat or to Q&A. Questions will be answered live after the lecture or after the webinar via email. In case your connection is lost, wait a few moments and try to connect again. And notice that the webinar is being recorded. Mihael, please, the floor is yours.
Thank you, Mojca. Dobro jutro, good morning, good evening, and welcome to all participants to today's webinar. So on today's webinar, I will present the new Power portfolio from the Power Quality Analyzer, MI2922. So MI2922 is based on the new platform, and it is developed on the Android platform and certified according to Class A. It's a handheld instrument which is intended for long-term recording, analyzing the network disturbances, and for troubleshooting. If we check where this device could be used, we can see that it has a lot of capabilities regarding the harmonics and interharmonic measurement. So it could measure up to the 63rd harmonics and interharmonics and superharmonics from the range 2 kHz up to 15 kHz with 200 bins. So it's a perfect tool for analyzing power quality assessment. It could be connected to the low voltage, medium voltage, or high voltage electrical systems. And it's a perfect tool for energy consumption optimization and cost reduction measurement. Also, evaluating of power factor correction in equipment could be analyzed perfectly with 2992. Based on the memory, which is integrated in the instrument itself, and possibilities to insert external SD card up to 32 gigabytes, it could be used for long-term monitoring, more than 1 year, for example. With the simultaneously detecting of different anomalies, also measuring of temperature, could be used as predictive maintenance for measuring motors and transformers. And also for verification the network capability before adding new loads. Simultaneously with the recording, device could capture events like inrush currents, voltage dip swell interruptions, RVCs, and transients events. So 2992 is fully compliant with the latest version of IEC 61000/4/30 Class A. Certification was done in Swiss laboratory Metas, and all measurements were practically done in 1.5 months based on perfect development and possibility to use different integration periods in the same time. 2992 has the biggest LCD in the class. It's 10.9-inch color touchscreen display. We implement special step-by-step setup wizard, which enables the end user the very simple setup of the instrument from the connection for the selection of current clamps, selection of specific events, and drive is driven directly to the recorder when it's simple selection of profile and start it. Instrument enables live view directly on the LCD, monitoring the trends, specific events, transients, inrush current alarms, and so on. Internally, we have 16 gigabytes of the memory, which is used for the working memory and for this memory for the saving data. For the saving data, around 6 GB is available for the end user. External micro SD card is capable to use up to 32 GB. And limitation is not by the instrument, but by the Windows system. We also develop the new PC software for analyzing and automatically report creation. And new software is called MP Vision. Based on the Android platform, there is simple smartphone operation, like touchscreen gestures, system settings, remote access. It's also implemented inside VNC Viewer, so you can easily access to the instrument remotely from your office. And you need to connect the instrument over Ethernet or external Wi-Fi router or GPRS router. Special function in the instrument also enables online firmware update, which is automatically downloaded from our server. There is a wide communication support. So we have for communication USB-C port. We're enabling communication as normal USB, but also USB via Ethernet port. So we can see all memories, internal and external, in the same time in MP Vision. If you connect just via USB, normal USB, you will see only internal memory, internal eMMC card. And USB-C port could not be used for powering the instrument, for charging the battery. It should be charged through the external power supply. Additionally, we have also Ethernet port, Wi-Fi interface, and Bluetooth inside the meter. If we are focused on technical highlights, we need to mention that we have sampling frequency 40 kilohertz, 40 kilosamples per second, comparing to the previous portfolio, which was only 7 kilohertz. And we use inside 24-bit resolution. And we need to point out that we analyzing all 9 channels simultaneously. Why 9 channels? So we have 4 current inputs and 5 voltage inputs. Also, neutral and ground are galvanically isolated between each other, so there is no internal connection between neutral port or ground. So there is no connection between metallic part, like USB case, with the neutral or ground system. So instrument is totally isolated. You can connect up to 1000 volt RMS or DC directly to the instrument. For connection to the PV installation, photovoltaic, so we are developing a special PV probe, which enables direct connection to 1500 volts. This will be available, I'm expecting, the period of 1 month. Current inputs, we have 4 current inputs, where you can connect current clamps or special temperature sensor, or current clamps, which are used with 2892, for example, could be used also here. We also enabling smart clamp recognition and optimal range selection automatically by the instrument itself. We are supporting 4 frequency ranges, basic 50-60 Hz, also 400 Hz for aviatics and Navy, and also VFD, which is covering frequency from 5 to 130 kilohertz. VFD means variable frequency drivers, which is used for controlling the motors. DC voltage and current is directly supported with the frequency support 50 or 60 Hz, where is also analyzed as a special case. Based on specific design, we're enabling category 4 600 volt, which enables the installation of the memory of the instrument directly in the transformer station in the category 4 environment. Internal backup is Li-ion battery with 4.4 ampere hours, and backup takes about 4 to 5 hours, depends on the battery state and the charging. And when you connect to the external supply, battery is automatically charged. Internal supply is from 90 up to 550 volts, AC or DC. So you can connect directly face-to-face voltage or face-to-line voltage, or directly to connect to outlet. So because of the biggest screen in the class, so the total sizes of the instrument is similar to the A4 paper list. And the weight of the instrument is around 2.5 kilo. If we are focused to the functionality of current clamps, we implement a new functionality which was requested from the market. And this was that you can select different current clamps for specific input. So in this case, we have three-phase view, when for each phase input and neutral, you can use specific current clamps. For example, you use a flex clamp for the input 1, DC clamp for input 2, and the third type for the input 3. We have also total view when all phase clamps are joined together, and setup is done only by the simple click on the clamp wrench, ratio enable, and Y direction. In case that you specify each clamp specifically, you can specify specific clamp wrench for each input, ratio for each input, and you can invert direction separately for the inputs. We're also supporting auto wrench. So this is available for the current clamps, which has more than one range. For example, our flex clamps normally has 3 ranges. For example, 30, 300, or 3000. And during the operation, during the recording, some instrument automatically adopt the most appropriate range of the clamps. There is also specific functionality which is called auto set. And in this case, the instrument will find the optimal actual range in this moment for the selected clamps. Measuring capabilities of 2992. So if we are focused to the input terminals, so we have the red one is for external supply, specifically denoted. Then for current inputs and 5 voltage inputs with neutral and ground terminal. So we are measuring and analyzing specifically true RMS value, DC and fundamental values. Then for each channel, peak and crest factor. And we are supporting different type of connections and also connection for specific photovoltaic inverters or UPS system, where you connect simultaneously AC voltage and also DC for specific analyzing. And in this case, DC is presented also with the ripple factor and also efficiency of the system comparing AC and DC parts. Regarding the harmonics, we make a step forward. So we are measuring harmonics and interharmonics up to the 63rd order, and also supraharmonics from 2 to 15 kilohertz with 200 hertz bins according to the standard. So which devices are generating such supraharmonics? For example, photovoltaic inverters or electrical vehicle charging station. So you can monitor the main frequency of such equipment. Regarding the THD and TDD, total demand distortion, we are supporting total harmonic distortion for current and voltage, and total demand distortion for the measurement. For total demand distortion, as load current is used the nominal current of the current clamps, so we need to recalculate later to the maximum current which achieved during the measurement. You need to do this with the MP-Vision software. Implement also bar presentation of power harmonics. So you can, in each moment, you can monitor which harmonics are generated and which harmonics are getting accepted from the network. So this is simply visible in the Power Harmonics bar graph. Based on the event and disturbances, so instrument could simultaneously measure voltage dips, swells, interruptions, then RVC, rapid voltage changes, transients, inrush currents, signaling, and up to 10 custom user-defined alarms. Based on the power and energy, we are following IEEE 1459 standard. So active, reactive, apparent energy and demand is measuring accordingly, divided to the combined, fundamental, and then non-fundamental part. And energy measurement is done in accordance with IEC 62053/21 standard. A huge improvement was done in the recording features. So we are supporting integration intervals from 200 milliseconds up to 2 hours. For 200 milliseconds, we create a special profile where is the specific register defined, and the registration period is only 200 milliseconds. So what is included inside, you need to check in the user manual, where each our defined profile is explained with what is included and which integration period are defined. We also create specific profiles, predefined profiles for standard measurements. For example, 5160, IEEE 519, or specific código de red, which request specific integration periods and specific registers. We specify directly in profile what is included. For example, for 5160, we specified harmonics up to the 25th, what is requested by the standard. And only 25 is included in the record. But if you create your own profile, you can use so-called user-defined profile. When you specify directly on the instrument what will be included, what will be the integration periods, and so on. There is also possibility that with special tool, end user will define custom profile for its own creation. During the recording, instrument automatically record events and also other anomalies like inrushes, RVC, transient alarms. So depending on the SD card and measuring interval, you can monitor long term. For example, for 5160 profile, you can monitor more than 1 year. With 200 millisecond profile, you can monitor more than 1 month. So now we'll check so what we have inside the specific events which are recorded, how they are presented on the instrument. So voltage events, so dip, swells, interruption, are presented with RMS halfway inrush samples and waveform view. So it means waveform samples which are sampling with the frequency 40 kilohertz. For the RMS preview, we can record up to 10 seconds with 1 second per trigger. But for a waveform, it's only 1 second with half second of per trigger. This is because of huge data which will be created, which will record 10 seconds. So each record will normally, it takes about 600 megabytes of the memory. For the RVC record, using RMS halfway samples, and you can record up to 10 seconds for each event. Same for inrush current recorder, RMS halfway samples, and we can record up to 1 minute. Alarms and signaling are sampling with the 200 millisamples, and alarms are recording 2 seconds for each trigger event, up and down. And signaling could be up to 2 minutes. Transient recorder are capturing events up to fixed number of 50 milliseconds with a sampling frequency of 40 kilohertz. Based on a color touch display and the dimensional display, we are enabling also live measurement and oscilloscope view in the instrument. So all trend charts for all online recording parameters could be monitored on display. So there is also a new function when you connect the voltage, and if recording is not started, trend is working, which was not case for the previous platform. You can also monitor all recorded events in the network simply on display. You can make a preview or pre-analyze on the instrument itself, also during recording. And the whole harmonic analysis could be checked directly on the instrument. So we have multiple communication channels. One port, which is USB-A, type 2.0. So it's used for the copying data from the internal SD card or external card. Just a simple copy and paste on the instrument, on the PC. So then you have USB Type-C port, which is used for data downloading. So I have already mentioned that you can use simple USB functionality or USB over Ethernet. You also, then you have RS-232-PS2 port, which is used for the GPS receiver connection. So in this case, time on the instrument will be synchronized up to 1 millisecond resolution, and also instrument will detect position of the instrument, which could be also presented then later with the Google Maps in the NP-Vision software. Internally, we also have NTP time synchronization. So when you connect the instrument to the Ethernet, you can it will simply automatically synchronized. So you need to synchronize it manually. Then we have our Ethernet port, which could be connected directly to the LAN network or to external GPRS Wi-Fi modem. There is VNC remote access possibility inside the instrument. So this means you can remotely connect or monitor your instrument from your office. So you don't need to go to the measurement place to change some parameters. You can simply do this by the click on your PC. And also it is used for remote or local data download. Internally, we have Wi-Fi and Bluetooth interface. Now this is example how to connect the instrument via VNC. So we have two instruments located in our transformer station, and this is example how we can remotely connect to the instrument and remotely operate it. This is running instrument. This is example of recorder view, which is running. So specific profile which is connected, and elapsed time. So this record was started 34 minutes ago. So in the basic recorder view, you have phasor diagram with all nominal values of voltages and currents. You have a device manager option, so you can create different setup, which will enable you faster and easier setup later when you will operate it. And also, you can make snapshots. So if there is something interesting during the installation, during setup, you can simply make pictures, and then you can use it later in the report. So we have so-called speed dial button when you can automatically set up or select specific operation. So we provide, so as already mentioned, recorder screen. Then we have live measurement screen, which is divided to 9 different functionality: voltage, current, power, energy, phase diagram, flicker, harmonics, and so on. If we look deeply inside voltage current screen, it's similar operation for all of them. Voltage current frequency will present you the main information about voltage current and phase diagram. Later with the scope view, you can monitor each voltages and currents. it voltages and currents. So for further analyze, so you can stop the scope view and you can monitor by the cursor to see some specific anomalies which is happening here. So under trend view, normally you monitor preselected values. So to enable the smoothly and easiest operation, we specified for each connection so-called default view. And under default view, it's for each measurement is specified what will be visible. For example, voltage, current, and frequency view, default view automatically gives you to select voltage, current, and frequency. You can select up to 8 different parameters. And you can save it. So if you need to add additional one, you can simply select it. The view and approach is the same as in the MP Vision. But to reduce the time, we prepare this default selection and default view. Now I have selected 7 different registers. They are presented in one epsilon scale or axis. So since the scale is different, I can simply deselect what is not needed at this moment. For example, for better and detailed analysis of the frequency, I have select only the frequency view. Then, for example, to select currents, I'm shadowing the other which is not needed, and monitor only the currents which are presented. And same for the voltages. Example, this is enable the faster and easiest view of the selected events. And you can, of course, you can make a screenshot if you need it. So practically, each view which is selected is done in the same way. Main screen details, for example, for power is combined fundamental and non-fundamental part, and total view of all interested registers. And same trend view with predefined selected measurement, what could be selected. So normally you will select one view, and which is then is saved automatically. It will automatically appears for the next time. So you just make stop on the harmonics view. So for the harmonics, as I mentioned, we are measuring up to the 60 third harmonics for voltage and current, and also interharmonics. Harmonics are presented in specific view, like absolute view related to the absolute value, related to the RMS or fundamental. So you can monitor a specific phase separately. You can stop it if you need to analyze. You can switch then to the interharmonics view for the voltage and currents. Also, interharmonics could be presented in the absolute value or related to the RMS or fundamental. And a specific one is supraharmonics. Supraharmonics are presented only for the voltages, since the most of the current clamps are not supporting a frequency higher than 4 kHz. Specific current clamps should be defined if you want to measure supraharmonics. Then we have power harmonics view, which is available for 4-wire connection, not for free or open delta, because it's related to the phase measurement. And we can check which harmonics are generated and which harmonics are imported from the network. So this is direct online view. Meter screen, which is numerical data, and you can sort by the voltage. So you can see which voltage harmonics is the highest one, so or related to the current. And if it's non-sorting, so you can simply, by the numerical order, you can check it. So in the start, I have mentioned setup of the instrument. So we'll go through the step-by-step wizard. So we need to stop the recorder and go to step-by-step wizard. Step-by-step wizard will directly drive you to the setup of the instrument. And the first question, which working copy you want to operate? The current one, current setup which is used, or create a new one? In this case, you will use the current one. So the first step is selection of connection. So you can connect whatever you want. For example, in this case, we will use Hribar connection. You have also example and help what to connect and where to connect. And additionally, you have how to say, evaluator of the value. And with the click, you have pop-up with the status, which is pass or not okay. So if the measured value is not within the specified or expected range. So the next step will drive you to selection of nominal voltage. Then you select simply nominal voltage, which is of the network, and selection of voltage transformer if it's used or not. For example, transferring the measurement to the primary side. And additionally, also this phasor diagram for easy orientation is also presented. On the next screen, so you have clamp setting view. In this case, we have phase view of the clamps because we have different clamps for a different current input. If you want it to join together, it's not possible because there is a pop-up note. So clamps must be of the same type. If they're not the same type, you cannot join together. But you can specify specific current range for this clamp is, for example, X600, 6600, 6000 or auto, and we're using, in this case, automatic range. An instrument will automatically select the optimal range during the operation. So we can see that these two clamps are set up to 600 amp, but the third only to 300. So because different type of clamps, and current is okay for 300 amps. And we have also auto set button. When we start it, it will automatically start the setting of the optimal clamp range. If we set it, so instrument will start with the highest range of the current clamps. It's already changed to the next one. And now it's analyzing if this selected range is optimum for the active current. So since this is takes up to 1 minute, because the value of the current must be stabilized, and we will see the final result now in a few seconds. And maximum time depends on the saturation of the electronics and could take up to 1 minute, as I have already mentioned. Now we'll wait that current will be presented. And also when you select auto range, and when during the changing of the range, it's possible that you will not have some result for the specific period, integration period, especially if you use 1 second or period shorter than 1 minute. So now the value was stabilized and optimum current range was selected. So last setup is related to the frequency selection. So you can use 50, 60 VFD or 400 Hertz, and also synchronization channel, which you suggest, which you can select between voltage and current. And since the voltage is much more stable, that current, so we suggest to use the voltage channel. So if you are satisfied with the connection, also with the online connection check, if we have yellow or green arrows, we can going further, which is driving us to set up of the network events. Normally for the voltage events, RVC, you have this the setup according to standard. You can change it if you can want. So you can change voltage events, RVC, and other network events which are changing, which are defined by setup, default according to standard. You can change it if you want, but if you're satisfied, you can use it as it is. So just confirming this, continue, it will automatically drive you to the recorder screen, when you can define which recorder profile you will use. As I have mentioned, we have user-defined profile, when you can select everything by yourself, what is registered. Then predefined profile, which are 200 milliseconds, code decoded rate 5160, energy demand IEEE, and Korean profile. We select user-defined profile, and we select general recording interval 10 seconds. For demand 10 minutes, with recording min, max, and average value. Frequencies, for example, up to 55. Also, medium supraharmonic will be measured, and will record periodics, voltage events, and RVC. Then next step is recorder. Start it, and instrument will automatically recalculate which registers are selected, and then will count down, and start of recorder will be synchronized with the real-time clock on the instrument. So it will be synchronized with the clock. If we now check and go to live measurement view and monitor the trend, so you will see that it will appear after 10 seconds, appears the first event, and then all events will be joined together will be added together on the screen. So for the reading the instrument, so we have access, remote access. If it's connected to the modem or LAN, so you can see Ethernet IP address. And for remote access, you have two passwords. One is for MP Vision access, and the second one is to VNC access. So you cannot connect it to MP Vision or via the VNC if you don't know the right password and right serial number of the meter. Now I will go back to the presentation. So approach what we are providing is also same approach as for the previous power quality portfolio, and also free sets are available, advanced with flex, tiny flex 1500, Euroset with old flex type 1227, and standard set without current clamps. We include by default magnet tips, which are perfect tool if you need to connect to the voltage to the RCD or to the fuse. Test tips and SD card are not included anymore in the set. Test tips are not perfect tool to using it, but SD card, you have 6 gigabytes on the instrument itself. Optional accessory which we are offering is GPS receiver, Wi-Fi, GPS router, monitoring cable, SD card, industrial type up to 32 gigabytes, safety flat clamps, and wide selection of AC, AC-DC, flexible clamps, or voltage current reducer. So the last part is software, which is MP Vision. So it's new developed software with the new graphic libraries, which enables better and faster presentation. And MP Vision automatically provides powerful data acquisition, analysis, and reporting tools, automatic report creation. The reports supported in the present moment is 5160, IEEE 519, configure and custom report. Also analyzing events, flickers, harmonics, specific heat map view, and is available remotely data download via USB or Internet. Data could be exported to Excel, Word, or a common separated value format. So if we check where to download the data, so we're offering the remotely download for the instrument, or directly import from the file. For a remote instrument, we need to select IP address of the instrument, serial number and password. We need to connect it, the basic data of the instrument, then listing records. We'll read this one, or this one is shorter. Download the data. So comparing the data transfer, comparing to the previous one is not comparable. It is much, much faster. For example, few gigabytes of data imported directly from the PC in the second, comparing to the previous one, which was taking few hours in some cases. So in the basic record information, you can see that we have internally different registration periods, not like simple one period like the previous portfolio. So you have 3 seconds interval, 10 seconds, 1 minute, 5, 10, 15 minutes, and 2 hours interval. We prepare some specific visible nodes. Here example is one demo view where it automatically pre-selected register which are selected, defined by the user. So you can specify your own approach, what you want to see. So you can see here that, for example, in table with 10 seconds will present frequency value, which are measuring according to the standard interval. Then you have 5 minutes, which is general recording period, voltage current, and 15, which was for demand. So with the trend chart, you can extend specific trend, perform different markers. Go to some different view, for example, measurement distribution, which is a Gauss distribution of the data, and also with the percentile calculation of the data from 0.5 percentile up to 99.5. Then specific analyzing of the actual data with min, max, and average value. So you're preparing also the specific so-called heat maps, when you can monitor the overview in the whole recording time of the specific harmonics. Here we can see, we'll extend this, for example, up to the 16 harmonic components. And you can see that during this period of time, the third harmonic was the most influenced. This is because of before the New Year, so the working day, when the third harmonics has the most impact, and also 5th, 9th, and 7th. You can change the harmonic monitoring range, for example, from 24 to the 50. So you can spread this range, so whatever you want. So this was shortly from my side. So now, Moza, so the stage is yours.
Mihael, thank you very much for your great presentation. Now we will continue answering your questions from the chat and from Q&A. Yanis, will you take over?
Yes, Moza, thank you. Thank you, Mihael, for the presentation. We have few questions. So starting by the simple one, like how many hours the instrument can work without the power cord connected. Mihael.
So normally backup time is from 4 to 6 hours, depends on the battery stage, if battery is fully charged and so on. But minimum 4 hours is confirmed.
Okay, the next one, how we compare the superharmonic range, like 150 kilohertz against 15 kilohertz. I would say the 15 kilohertz perfectly suited for power network analysis, and 150 kilohertz is more for, let's say, academic research on insulation, EMC, and usually this level 150 is more oriented to research on insulation and electromagnetic compatibility. More localized and not so important for utilities or power networks. So that's why we were focused first to support this type of superharmonics. So maybe Mihael can add something more.
So superharmonics are divided according to the standard into ranges. So one is from 2 kilo to 9 kilo, and the other one from 9 kilo to 150 kilo. And also for the highest range is defined to 200 bins. So you will have at least a few thousand superharmonics for each view. So definitely this probably, I don't believe that it will be obligatory to measure it. There will be some how to say, some guidance how to operate it, but definitely not all instrument will support it also in the future, because it's totally different design, different management and measurement system. So we're supporting now up to 15 kilo with the system what we have with the sampling frequency, and probably will increase this superharmonics later. But as Janne said, 150 kilohertz is still like in the foggy, and only experienced guys can operate and analyze the total system.
Yeah, where it depends where you work, where your customers are operating, and who are the potential customers. So where we are talking about the power quality suited to IEC 6100047. So this standard is focused up to 15 kilohertz. If you are EMC guy, then working in some laboratory, academic research on insulation problems and so on, maybe also the electronic devices, then 150 comes in more local. So you do not, you see a lot of noise together with superharmonics in this range. So not for the network guys and utilities. Okay. Furthermore, we have a question about comparing two models from the range 2892 and the new one 2992 models. Mihael?
So the first point is sampling frequency, LCD, touch display, communication capabilities, independent registration periods, profile creation. So you can get also the comparison table, what it is. But comparing to 992 and 2092, so it's a huge difference from the what is available for your analyzing.
When we compare two instruments and the accessory, are the accessories compatible from one to another, like current clamps? And also the question is focusing on the range, how low we can go with the testing current range.
So all clamps, what you have on the stock or what you're using with the previous PQ family, you can use it also with the new one. The minimum range depends on the clamps. So if you have some specific iron clamps, you can measure from the milliamps and up to 12 kiloamps with the highest flex clamp. So the same batch of clamps would be used also with 2992. Current input accept the signal up to 3 volts, which is normally could be generated by the current clamp. So there is no specific limitation comparing to the previous one. But as I mentioned, so minimum current is related with the selected current clamps and not by the instrument.
Another interesting one about the IP65 outdoor case box, like we have for the PQA range in 28 range of models.
Yes, we will prepare it in the same approach like for the 2892, the same case with the additional case on the top, so it will be ready soon.
Maybe some words about the future plan, where we would focus in the future, whether we will have the 1 megahertz sampling rate available in the 93 model, or how we plan for future.
Yes, we have in the final different models, also how to say lifting of the existing portfolio and also new version based on the Android with the highest sampling range. This is in the funnel, and we'll see, depends on the measurement or the management plan, what will come the first one.
Is the device compliant with IEC 62506?
So we have done certification according to class A. I need to check specifically with this standard what it means and can answer it later. So I need to check specifically what is inside this standard. Is this measurement techniques or something like this? I need to check it. I don't have it now, this number in my head directly.
The next one, the connection directly to 1500 volts.
As I have mentioned, we're preparing special PV probe like attenuator, so that you can directly connect to the PV system to 1500 volt. It will be ready soon. Special adapter. And
for the last, the meaning of MP, which stands in MP Vision.
MP Vision means Metrel Power Vision.
Great, Mihael, thank you. I believe we come to the end of the next interesting field. So thank you very much to join this webinar, and back to Moica.
Thank you, my colleagues. Thank you, Janez, and thank you, Mihael, for another very interesting webinar. We hope that we enlightened all the important information about our new Power Quality Analyzer 2992. Dear participants, thank you, and dear partner, thank you for visiting our webinar. And in case you have additional questions, please send them to academy@metrel.si. So thank you for joining us, and see you next time. See you soon. Bye.